We are today looking at introduction to polar functions and polar graphing. Are you with me there, Thomas? All right. So up until now, we have graphed on a rectangular plane. So just a normal XY axis. Just a normal XY axis. This is the rectangular, I don't think I need it, rectangular coordinate plane. And, but now we're going to look at another different kind of system. So we're going to look at another system called the polar coordinate system. And so it uses ordered pairs, but they're just a little bit different. So here, we have this sort of point O here. It is what we might consider sort of like the origin on our coordinate plane, normal coordinate plane. So you can imagine that is sort of like the origin, and we call it the pole. So point O is called the pole, or you can call it the origin. But it is very much like the origin of our XY coordinate plane. And we have our initial ray called the polar axis. And this is the initial ray right here. And it runs on, basically on top of the x-axis. So that's basically our initial point, our initial ray. And what we're really graphing here is really graphing angles. Okay, and so each point P in the plane is assigned a polar coordinate, r theta. So you can see right here, what we've done here for point P is we've opened up an angle, and we've gone a certain distance, r. What do you think r stands for? Radius, absolutely. Okay, so we've gone a certain distance towards that angle. And r is the directed distance from the origin to point P. So it is a distance, like a radius. And theta is the counterclockwise directed angle formed. So we typically go counterclockwise motion, just like we would normally open up our angle pi over 4, pi over 3, pi over 2, just like we normally would. And so we're basically opening up an angle and then going out a certain distance, the radius, okay? But we do have one little, this is the trickiest part. When r is negative, we do something a little different. We graph the point, I'm going to write it out instead of doing math. We graph the point in the opposite direction. Exactly opposite direction. So I'm going to show you on the next one. So we graph that in the opposite direction when the radius is negative. So it's sort of like instead of graphing it towards your angle, we go exactly the other way. Sort of goes exactly the opposite way. All right, so we're going to practice graphing. Okay. We have, this is what a polar graph looks like here. It's a little faded. I apologize for how faded it appears, but I hope you can read it. You can see that we have the mark here at, what marking is that? Pi over 6. We have right here is pi over 3, pi over 2. So these are our normal graphs, but we've taken those and we've split them. What is this point? Pi over 12. Very good. And so really you could count pi's over 12 all the way around here. But it is just our normal unit circle, essentially. But they've divided it into pi's over 12 instead of just pi's over 6. So here I want to graph and label each point on the polar grid. So this is our polar grid. We have an r of 2 and a theta of 7 pi over 6. And so I'm going to go to 7 pi over 6, which is right here at 7 pi over 6. And I'm going to go out a radius length from the origin to that 7./6. I'm going to go out 2 units of length, which you can see the 2 is labeled. So I'm going out 1, 2, right there. That is point A, right there. Does that make sense to you? Yeah? Okay. So again, we have r and theta. So on number 2, 3 pi over 4, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, right there. So there's 3 pi over 4. And I need to go just a half a unit in length. So half a unit would be right here. Right there is B. You don't have to graph the actual angle itself. You could just graph the point, but I'm kind of enjoying drawing it to the point there. All right, so here we have our radius of 3 and our angle of negative pi over 3. So what do we do when our angle is negative? Yeah, we go clockwise. So now it's opening downward. So where is negative pi over 3? Yeah, it's right here. So that's negative pi over 3 right there. And we want to go 3 radiuses length towards it. So that is 1 hole, 2 holes, 3 holes. There it is. So there's point C. Okay, those were all positive radii. So they all head toward the angle. Oh, I'm sorry. You're right. Sorry. I didn't look closely enough. It's very hard to see. So there's 5 pi over 3. That would be the negative pi over 3, same thing. And we're going 1, 2, 3. There we go. So there's point C. Thank you, guys. Good catch. Good. Okay. I love that my pen's erased. That was handy. Okay. Here we have a negative radius. That's going to go away from our angle because it's negative. So I'm going to go to my angle theta, which is at pi over 4. Pi over 4 is right here. Normally, I go 1 unit towards the angle. But because it's a negative radius, I'm going to go exactly in the opposite direction. So I would be going backwards 1 whole unit. So there is point D. It goes away from the angle. So what angle is it headed toward? 5 pi over 4, I think that's right. 5 pi over 4. Yeah. So it's just going exactly in the opposite direction, away from the angle instead of towards that angle.
Please excuse the interruption. At this time, please release the high school track team. Thank you.
Good luck. All skill, baby, all skill. My daughter had her first track meet yesterday, and she passed out at the end of her 2-mile. She hit the deck, and she's all banged up, poor baby. Okay, here we go. So again, we have a negative R value, so we are going away from the angle. 4 pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3. Right here is 4 pi over 3. So I would go normally towards the angle 2.5 units, but because it's negative, I want to go exactly the opposite way. So 1 unit, 2 units, 2.5. So all the way this way, there is point E, exactly in the opposite direction. You following along, Scott? Let's try again, right here. Our angle is negative pi over 6. That means we have to go down. So right here would be negative pi over 6. It lines up with 11 pi over 6. And normally I would go 1, 2, 3 units towards it, but because it's negative, we're moving exactly away from that angle in the exact opposite direction. So 1, 2, 3, it would land right here, and that is point F. Do you guys have any questions about graphing those points? Okay. So if we can graph them, and you'll notice that, for instance, we said point D had a negative R value. I want to be able to give it multiple names. Is there another ordered pair that I could write that would also fall at point D? Yeah, 1, 5 pi over 4. So that's, if the R was positive, it went towards 5 pi over 4. So every point can be named in multiple ways. So I want to look here at number 7. We want to name 3 different ordered pairs, but we could, actually there's 4 every single time. I want to draw a picture of this because I think that's really helpful. So I'm going to draw my little fake unit circle here. I'm going to take pi and I'm going to cut it into 3 slices. So here's pi, and I'm going to cut it into 3 wedges. So there's a 1 wedge, a 2nd wedge, and a 3rd wedge on top, and then my repeated on the bottom. All right, where's 5 pi over 3? Bottom right. 1, 2, 3, 4, 5 pi over 3 is right here. There's 5 pi over 3. And if that radius is 2 units long, then there's the point that I graphed it at. What's another name that I could get for this point right there? Yeah, we could use the negative angle to get there. So still using the same radius of 2, but I can use the negative angle, negative pi over 3. What else could I do?
Negative 2 pi over.
Very good. Yeah, there's this other angle exactly opposite right here. That's 1 pi over 3. This is 2 pi over 3 right here. If I choose a point that hits 2 pi over 3, if I go towards it, well, that wouldn't match up, but I want to go away from that angle, so negative 2 pi over 3 would work as well. You got another one? There are a million names. Like, we could literally give a million different names.
Like the
11 pi over 3. How did you come across 11 pi over 3?
Well, it wouldn't work, but,
Because
there's a domain.
Well, you could go a whole nother rotation, yeah. So this is 5 pi over 3, 6, 7, 8, 9, 10, 11. 11 pi over 3 would also get us there. So you can keep rotating as well to get an infinite number of points. We could also do the negative angle this direction. So I could go negative 1, 2, 3, 4 pi over 3, negative 4 pi over 3, and go in the negative radius direction as well. Is that right? 1, 2, 3, 4, yeah. Oh, but yeah, so that one is out of bounds because they wanted it inside of 2 pi. I didn't even read the directions. That's what you were saying. I didn't even read the directions. All right. Okay. So lots of potential names for those. Let's see. We're going to turn the page. Not to the back. We're going to skip the back. We're going to do a little bit of graphing because I wanted to get you started on graphing. A polar equation is an equation expressed in terms of r and theta. So some examples, we could have r equals 5, just like you see here, r equals 2. We could have r equals like 2.5 sine of theta. You might see something like r equals -6 cosine of theta. But these are all polar equations because they use r and potentially a theta. This one does not, though. What do you suppose it looks like if it just is r of 2? Yeah, r of 2. You said before r is like a radius. So if r equals 2, it's 2 all the way around for all of our angles that we just don't care about because they didn't even mention the angle. All right? So r equals 2 is really just a circle. What's r equals -4.5? Yeah. So the only difference is, I mean, really, if you were to think about it, if we were to graph 4.5 theta of 0, well, we'd be right here at 4.5, but we're going in the negative direction. So it really starts this direction. It starts backwards, if you will. But it's still just a circle of radius 4.5. Regardless, positive or negative, still just a circle. What if our equation just says, hey, we want the angle pi over 3? What do you suppose that is? It's just a line, yeah. So where's pi over 3? Right there. It goes from the origin through pi over 3, and it does extend for any radius. So it is simply a line. And what would theta equals -7 pi over 6 look like? Yeah, so -7 pi over 6, excuse me, -1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. There's -7 pi over 6. And it is a line extended in both directions through that pole or the origin, okay? All right. Now, just like everything we do in math, when we graph, we make a table of values. And you can graph every single equation ever just using a table of values. And you can see we've got a bunch of values listed for this function, r equals 2 sine theta. We're going to plot the points and connect them into a smooth curve. So I want to know, hey, what is 2 times the sine of 0? Yeah, right here at 0, our ordered pair is 1, 0. 2 times 0 is 0. At pi over 6, what's our ordered pair? And then up 1/2, good. And so what we're doing is we're plugging in pi over 6, so we want 2 times sine of pi over 6. What's the sine of pi over 6? 1/2. And what's 2 times 1/2? 1. Yeah, 1. All right. Yeah, there's 2 in front. All right. At pi over 3, what's my ordered pair? √3 over 2. Very good. And so we want 2 times the sine of pi over 3. And what's the sine of pi over 3? Radical 3 over 2, yep. Times 2. Radical 3 over 2 times 2. Yeah, the 2's crossed out, and we just get radical 3. At pi over 2, I'm straight up. What's the ordered pair? 0, 1. So 2 times the sine of pi over 2 would be 2 times 1 is 2. Very good. What do you get at 2 pi over 3? At 2 pi, the ordered pair is -1/2, but it's up radical 3 over 2. So it's the same as the previous one. It's going to be 2 times √3 over 2, which would just be radical 3. And then at 5 pi over 6, 1. Again, it's going to be 2 times 1/2, which is 1. All right, I want to plot those just to see what that looks like. So remember, our ordered pairs are theta. So the theta is 0, our radius is 0. We're starting right here at the origin. So there's a big point right here at the origin. Pi over 6, we want to go out 1 unit, so I'm going to put a dot right there. And I'm not going to draw the little line. I'm just going to put the dot where it is at pi over 6 and 1. Pi over 3, and we have a radius of radical. What is the decimal for radical 3?
1.73.
1.7? All right. So at pi over 3, we're going to go 1.7. So it's almost to the 2, so about right there. And then at pi over 2, we want to graph a radius of 2. And then at 2 pi over 3, we're back to not quite 2. We're at about 1.7. And then at 5 pi over 6 angle, we're going to go out to a radius of 1. Let's try pi really fast. So pi is right here, -1, 0. So that is, hey, that's going to be 0 again. Oh. What do you suppose happens when I hit 7 pi over 6?
Negative.
It does become -1, yes, because now we're below, so all those sign values are negative. What do you suppose happens at 4 pi over 3? Negative radical 3. At 3 pi over 2, -2, negative radical 3, and then -1. It actually just graphs, if we were going to go to 7 pi over 6, we'd go in the negative direction. We're back to the same point we previously graphed. So, do we have to do it again? Yeah, we'll get there in a couple days. We're going to connect these points in the nice smooth curve, and what shape do you think that is? Also a circle. Wowza, isn't that cool? So these are functions that actually graph circles for us, and you'll notice this one, the sine function, it's sort of vertical. It's sort of on the vertical axis, if you will, if it was our xy plane. Just like our sine values are the y values, this is graphing on this quote-unquote y-axis, if you will, okay? Let's turn the page. Let's look at number 8 here. Oh my gosh.
I missed the old one. There was only like 3 problems with it.
Oh, well, we're not doing all of these. I look at number 8. So again, I'm going to make a little XY chart. And I'm going to choose, just like the last one, 0, pi over 6, pi over 3. Lucy, if you want it's up here, the packet, my dear. I just realized you probably didn't pick it up. Pi over 2, my handwriting, because I didn't do it digitally. Yeah, 2 pi over 3, that's okay. 5 pi over 6 and pi. What do you suppose is going to happen if I continue to wrestle way around? It just be repeats, sort of, yeah. Okay, so I have 4 times the cosine of my angle is what I'm plugging in. And again, I really just I'm thinking always about my unit circle. At 0, we have the ordered pair 1, 0. So this is 4 times the cosine at 0, which is 4 times 1, which is just 4. All right, at pi over 6, my ordered pair was radical 3 over 2 up a half. And so this is 4 times my cosine value. So this is 4 times root 3 over 2. What does that clean up to be? 2 radical 3, yep. 2 radical 3. I guess that'd be twice 1.7, so... All right, pi over 3 is the ordered pair 1/2. up radical 3 over 2. So this is going to be 4 times my cosine value, so 4 times 1/2, which is 2. At pi over 2, my order pair is 0, 1. So it's just 0. At 2 pi over 3, negative 2. Very good. And it's negative because we're in negative land for our cosine value. So that's negative 1/2 times the 4. And then 5 pi over 6 is going to be negative 2 radical 3. And then the last one would be negative 4. So let's see how that graphs. So 0, we're graphing the angle of 0. We want a radius of 4. So this is starting way out here, right here, with our angle of 0 and a radius of 4 length of 4. Pi over 6, so here's my pi over 6. I want a radius of 2 radical 3. I need 2 times radical 3. 3.5? All right, so about 3.5. I'm going to write that in. About 3.5. You could approximate that. So let's see. There is 3, and then a little more about there, right about there, between 3 and 4. And then at pi over 3, it's simply 2. And then at pi over 2, it's 0, so that is at the origin. And 2 pi over 3 is my angle that I'm looking at, but my radius is negative. What do? You go out the other side. You go in the opposite direction. So away from the angle instead of towards the angle. So right here, negative 2. And then 5 pi over 6 is right here, but instead of going towards the angle, our radius is negative, so it goes away from the angle. And that was about 3.5 away from the angle. And then we'll go back to pi. We're going away from the angle. That, again, lands us right where we started. What shape did this make? Another circle, but this one is sideways. It's on the, what I might call the x-axis, the horizontal, right? So it's sort of crossing the horizontal axis. This is the cosine function, and that sort of makes sense because cosine was our x-coordinate, so that is why it's sort of horizontal. All right, does that make sense to you? Okay. Don't teach it yet. I'm sure you can figure it out. So you can use technology. It says it right here. I guess you can figure that out. But then how do you put this one in? Smarty pants.
The secant 1 over all, the secant part of it. 1/2, and then in parentheses 1 over secant theta.
1 over
Or
cosine theta, yeah. So you can use your calculator. So if you grab your calculator, you want to change the mode to polar. And so you press the mode button and you'll see like function and then polar and then parametric. Did you find it? So click it to polar and then you can go to y equals and you'll notice that, yeah, it says r equals. And so in your calculator you could put this one in. So when you push X, it'll give you a different variable now. All right, did you see that now? Yeah. All right, and so go ahead and type this in sort of like this. Yeah, and that's how we get secant 1 over cosine. All right, did you graph it already? What's it look like? Yeah, isn't that kind of interesting? So I'm just going to do zoom trig. Hey, it's just that, wow, that's kind of interesting. It's just a straight line. it goes through, it's half of, so it's going right through the halves. It's just a straight line right through here, which is kind of crazy. Again, it's related to cosine, so it's crossing that horizontal axis. Graph number 11. Hello. Hi. I do. Okay. Okay. Bye. Yeah, trainer. Alright. Okay, so how are you going to put this one in the calculator? -2 times 1 over sine of theta, because cosecant is 1 over sine. What's it going to look like?
It's gonna look like a horizontal line.
A horizontal line, okay. Yeah. It goes through -2, and it's a horizontal line. Interesting. Again, it's related to sine, so again, it's sort of crossing that vertical axis, if you will. But these are, I think they're pretty cool to go ahead and just see what they look like. And we're going to play around with it a little bit more in a couple days. But there you go. You can see we get a cool little circle when we graph those. Okay. You guys have a homework assignment in here, so I need you to turn to it so you know what to do and what not to do. Paper, yeah. So you can cross off number 9 and number 10. Just turn the page, the next page. So you can cross off number 9 and 10. You can cross off 11 and 12. And cross off 9 and 10 and 11 and 12. And number 13. And you can do the back side. 14 through 19 is fine. Yeah. No, you're doing 1 through 6, 7, 1 through 8, 1 through 8, and 14 through 19. 1 through 8 and 14 through 19. That's what your assignment is. Yeah.
I could do that.
Okay.